Hi, my name is Emmanuel Peña and today I'm going to discuss about buckyball bearings. All natural sciences are affected by chemistry. The discovery was inspired by a desire to better understand the behavior of carbon in red giant stars and interstellar gas clouds. The discovery of fullerenes has broadened our understanding and altered our perspectives in chemistry and physics. It has provided us with new hypotheses regarding the occurrence of carbon in the universe. It has also led to the discovery of trace amounts of fullerenes in geological formations. Fullerenes are most likely much more abundant on Earth than previously thought. Most sooty flames have been shown to contain trace amount of fullerenes. The Royal Swedish Academy of Sciences awarded Richard Smalley, Robert Curl, and Harold Kroto the Nobel Prize in Chemistry in 1996, the most prestigious award in the world for chemists. For their discovery of fullerenes, they discovered fullerenes, or also known as buckyballs, in 1985, but it took a few years to prove and categorize the buckyballs' special properties. Although no practical applications of buckyballs had been developed by 1996, scientists praised the direction this organic chemistry-based discovery and led scientific research, as well as its specific contributions to various other fields. The unintentional discovery of fullerenes highlights the benefits and unexpected outcomes that can occur when scientists with diverse backgrounds and research goals collaborate in the laboratory. Before we get into the specifics of the buckyball, we should talk about the element that allows it to exist. In the first place, carbon. Carbon, the sixth element on the periodic table, has been discovered to be at least a partial constituent in more than 90% of all chemicals known to man. Indeed, its electron bonding properties gives it a carbon-specific versatility, allowing it to be so widely functionalized and, more importantly, providing the basis for life on Earth. Because everything that lives is chemically based on carbon atoms. Substances containing carbon are known as organic compounds, and the study of them is known as organic chemistry. Carbon can exist in pure carbon state such as graphite and diamond, despite the fact that it is involved in chemistry with a wide range of other elements and compounds. Graphite and diamond are two different carbon allotropes. An allotrope is a specific physical arrangement of an element's atoms. Although diamond and graphite are both pure carbon, their chemical and physical properties as well as value are vastly different due to differences in crystalline structure. Polyhedrons that resemble spheres are commonly depicted. C60 buckyball is in fact a truncated icosahedron. A better representation of it can be found in a soccer ball, which has the exact same shape. It is composed of 12 pentagons surrounded by 5 hexagons, so 20 in all. A British chemist, Harold Kroto, at the University of Sussex, was studying strange chains of carbon atoms found in space through microwave spectroscopy, a science that studies the absorption spectra of stellar particles billions of kilometers away to identify what compounds are found in space. This is possible because every element radiates a specific frequency of light that is unique to that element, which can observe using radio telescopes. The element can then be identified because a fundamental rule of matter is stating that the intrinsic property of elements apply throughout the universe. which means that the elements will emit the same frequency regardless of where they are found in the universe. However, Kroto believed that the chains were formed in the stellar atmospheres of red giants and not in stellar clouds, but he had to study particles more closely. Although buckyballs have not yet been used in any practical applications, partly due to the high cost of material, researchers are using buckyballs to learn more about the history of our world. And companies are devising some interesting uses for buckyballs even today. In their study, the researchers found helium of extraterrestrial origin trapped inside buckyballs extracted from two meteorites and sedimentary clay layers from 2 billion and 65 million years ago. The helium inside these buckyballs bears unusual ratios of 3 helium over 4 helium coupled with non-atmospheric ratios of 40 argon over 36 argon. According to their research indicators, they have shown that these fullerenes could not have been formed upon impact of the meteorite or during subsequent forest fires. These methods of producing buckyballs do deserve a great deal of applaud. However, humans cannot take all or even most of the credit for the production of fullerenes. As a matter of fact, buckyballs occur in nature naturally and in greater amounts than expected. Buckyballs are known to exist in interstellar dust and in geological formations on Earth. Even closer to home are the buckyballs that naturally form the wax and soot from a burning candle, as the flame on the wick provides the sufficient conditions for such processes to occur. Buckyballs are the new sensation for us, but to nature, they are old news. Buckyballs are now being considered for uses in the field of medicine, both a diagnostic tools and drug candidates. Simon Friedman, a researcher of the University of Kansas, began experimenting with buckyballs as possible drug treatment in 1991. Because buckyballs have a rigid structure, unlike benzene rings, often used for similar purposes, researchers are able to attach other molecules to it in specific configurations to create precise interactions with a target molecule. For example, Friedman has created a protease inhibitor that attaches to the active site of HIV 50 times better than molecule C60, a Toronto-based company that specializes in medical uses of fullerenes, plans to test on humans 2 new fullerene-based drugs for Lou Gehrig's disease and HIV in the near future. Another medical use for buckyballs is taking place in the field of diagnostics. Buckyballs' unique cage-like structure might allow it to take the place of other molecules in shutting toxic metal substances through the human body during MRI scans. Usually, the metal gadolinium is attached to another molecule and sent into the body to provide contrast on the MRI scans, but unfortunately, these molecules are excreted from the system quickly to reduce the chance of toxic poisoning in the subject. Lon Wilson of Rice University and researchers at TDA Research have encased gadolinium inside buckyballs where they cannot do harm to the patient, allowing them to remain inside the body longer but still appear in MRIs. So far, this application has been successfully tested in one rat. Wilson and others have begun to develop even more applications for tiny little cages that could one day help revolutionize medicine. Engineering uses. Nano STM, the scanning tunneling microscope, is one of the foremost tools in microscopy today. Boasting the ability to map out the topology of material surfaces at atomic resolution, the STM achieves the feat by bringing a needle point functioning as a probe within just several nanometers of a sample surface. At these minute scales, even small disturbances can cause the tip to crash into the sample and deform itself. A possible solution to this problem would be the replacement of the standard needle point with a buckyball. As discussed previously, fullerenes bear amazing resilience due to their spherical geometry and would resist distortions from such collisions. Buckyballs in circuits. European scientists are aiming to use buckyballs in circuit. So far, they have been able to attach a single fullerene to a copper surface and then through a process called shrink wrapping, fitted its center with a metal ion and made it smaller to increase electric conductivity by 100 times. Lubricants, because of their shapes, they could be used In conclusion, as we can see, we have come a long way since that fateful year of 1985. Strides have been made. We have seen the rise of nanotubes and the new science of nanotechnology. We are still studying the chemical and physical properties of buckyballs and continue to be amazed. They have already proved to us why they are important. Their possible uses in medicine and engineering are broad and profound, while the health risks they pose have yet to be fully analyzed. Only time will tell whether they will meet or exceed our expectations as we unfold this brave new world.